students, welcome to mathgotserved.com. In this clip, we're going to be going over problems 25 to 29 of the August 2016 Algebra 1 New York Regents Common Core examination. Our goal here is not just to show you some tips and tricks to get the correct answer, but we are also going in depth into the mathematics behind why we're getting the results we're getting. Alright, let's take a look at question number 25. Here we're asked to graph the function y equals negative square root of x plus 3. Okay, and then a set of axes is provided for you. Now, one tip concerning graphing functions, of course you can use your calculator here, is that when plotting graphs, you want to be strategic. Okay, when plotting graphs, you want to pick points that are easy to graph accurately. Okay, so what am I talking about? I'm talking about lattice points. If you can graph just lattice points, points that fall on the intersection of the x and y calibrations, then those are the points you want to graph because it helps you generate a much more accurate curve. Okay, so we're going to be taking advantage of the fact that we can use the graphing calculator to help us generate a table of values, and then we're going to be selective. Okay, we're going to be picking points that can help us graph the best looking curve. Now, before we even start graphing, if you take a look at this function, can you picture what the function is going to look like? Well, this is a radical function that has been reflected downwards since a is negative and has been shifted 3 units to the left because you have a plus 3. So let's say you have a radical function looking something like this. You're going to reflect it down and shift it to the left by 3 units. So this should be what your final product looks like. Let's see what the calculator has to say. So what we're going to do now is enter the function in the calculator. The graph will give us a general idea as to what it looks like, but the main thing we're going to be extracting are the coordinates. Okay, we're asked to plot the points. Alright, let's graph it. We have negative. Remember, this is just a sign, it's not an operation. So negative square root of x plus 3. Enter, hit graph. As you can see, we have a radical function that has been reflected downwards and shifted 3 units to the left. Now let's take a look at the table. Remember, as indicated earlier, you want to pick points that are easy to graph. We have the undefined values here, ignore those. If you look at the x, we're looking for y's that are whole numbers or fractions that terminate early. Okay, so we have negative 3 is excellent because we have 0. Negative 2 is negative 1, good. Negative 1 has this decimal expansion here that looks like root 2, but let's skip that. Skip 0. You see 1 looks perfect. And let's see if you have another one. And 6 is perfect. That's more than enough, okay? So let's pick up the coordinates that are easy to graph, the ones that fall on the lattice points. We have negative 3 is good because with negative 3 we have an output of 0. That's easy to graph. Negative 3 goes to 0. And then we have negative 2 is nice too because that goes straight to negative 1. Skip all the way to 1 because we have a nice output there, which is negative 2. And then lastly, I think we did, what did we do? We did, was it 6? Yeah. 6 took us to negative 3. Alright, so these are the points we're going to plot on the given axis, and then we will connect the dots to create our transformed radical function. Okay, so let's go ahead and graph those points. First one is negative 3, 0. So 1, 2, 3, negative 3, 0. You see how easy it is to graph if you have nice input and output values. and it also makes it more accurate. Okay, negative 2 goes to negative 1. 1 goes to negative 2, 1, 1, 2. And then we have 6. 1, 2, 3, 4, 5, 6. 6 goes to negative 3 right there. Alright, so this is negative 6. Oh, sorry, that's positive 6 actually. This is 6. This is 1. This is negative 2. And this right here is negative 3. Okay? Now let's connect the dots. We know what it looks like, right? So we just follow the same pattern as illustrated on the graph to connect the dots. We can use calculators, so we might as well take full advantage of it. Okay? So through there. My line is kind of wiggly, but it's okay. Do that portion. So, and then it just goes on in that direction forever. So that's the graph of y equals negative root x plus 3. Alright, let's take a look at question 26. It reads, Richard is asked to transform the graph of b of x below. Okay, so we have this function right here of b of x. The graph of b of x is transformed using the equation h of x equals b of x minus 2 minus 3. Describe how the graph of b of x changed to form h of x. Okay, so this is a transformation problem. Some points you might want to recall. If you have a function of x minus h, okay, you have a number subtracted from the x in the parentheses. This means that you're going to shift h units, guess what, to the right. This one is backwards, okay? Because when you see a minus, you assume, oh, we're going to the left, but no, it goes backwards. If you have a function minus a number, okay, in this format, you're going to shift k units, guess where? You're going to shift k units up. This one, it makes sense. I'm sorry, k units down. So you're going to shift k units down. For the vertical shifts, up and down, you just follow the sign. But for the horizontal shifts, left and right, you do the opposite. Okay? Now, in this problem, we have the transformed function h of x, which is b of x minus 2 minus 3. Here we have f of x minus 2 because of the b of x minus 2 here. Now, what does this one tell us? X minus 2 means you're going to shift 2 units where? Whenever you have minus grouped with the x, you do the opposite, 2 units to the right. Okay? And then you have minus 3 there, which can be written as f of x minus 3. This is a vertical translation. In this case, you're going to shift 3 units down. Okay, so that's basically what the answer is. So for the transformation, our answer h of x is going to be, you're going to shift 2 units to the right, and 3 units down. 3 units down. And then just a side note, this translations are on, you're starting from G. Okay, so B. So you're starting from B of x, and then you're carrying out the transformations on B of x in order to go from B all the way to H. Now let's take a look at problem 27. It says, consider the pattern of squares shown below. Which type of model, linear or exponential, should be used to determine how many squares are in the nth pattern? Explain your answer. So this is basically a sort of multiple choice question, but we have justification or explanations attached to it. Why do I call this a multiple choice question? Well, we're told that if you examine this pattern, is the nth pattern, is the model, is it linear or exponential? So it has to be either this or this. And then whatever your answer is, you will have to back it up with an explanation. Okay? So something I'd like you to recall or note concerning linear and exponential models, let's write that down. So something to note is that linear models have a constant growth rate. They have a constant growth rate. Remember that m in y equals mx plus b, now that's always constant. It doesn't change. For lines, you always have a constant growth rate. Okay? Exponential models, on the other hand, exponential models do not have a constant growth rate. Now, this is something you want to keep in mind. If a function does not have a constant growth rate, it doesn't automatically mean that it is exponential. There are other functions out there with growth rates that are not constant. But in this particular problem, remember, as indicated earlier, this is kind of like a multiple choice question. We are restricted to either linear or exponential. That's why we're focusing our attention on just these two. Now, let's take a look at the pattern. We have the x's, which is basically the position, and then the y's, which is the number of blocks that we have. So the first one has 2 blocks, or 2 squares. The second one has 1, 2, 3, 4 squares in it. The third string of box squares has a total of 8 squares in it. Okay, so we have our nice little input output tables here, so we can easily determine what the growth rate is. Now, when we're talking about growth rate, it's the same thing as your average rate of change or your slope. Okay, so that's changing y over changing x. The increments in our x's are just 1s, so whenever you divide anything by 1, you will get that number. So we're just going to focus on our change in y's. Alright, so from 2 to 4, what's the growth? That's plus 2. Okay, and then from 4 to 8, what's the growth? That's plus 4. What do we notice about the growth rate? Is it constant or not? It is not. It's changing. It's increasing. Typical of an exponential function. So side note, the growth rates are not the same. That basically automatically eliminates the linear function from this scenario. It can never be linear because linear functions have constant or the same growth rate. Now, let's go ahead and write down our explanation. Okay, remember, when you're asked to explain your answer, you have to include your explanation in order to get full credit. So in order for us to appropriately construct our response, you might want to revisit the question and reread what the question says, because you are going to convert the question into an answer format when constructing your sentence. Okay, so it says, which type of model, linear or exponential, should be used to determine how many squares are in the nth pattern? So we just answer in that format. Okay, so based on our results, the model that we're going to use to find the nth pattern is the blah. Okay, so keep that in mind. Now, let's start with our justification. Okay, so from the results we have here, we know that the growth rate is not linear, so we're going to be using exponential. We have to include that in our explanation. So The growth model, the model that should be used to determine the number of squares in the nth pattern is the what? Is the exponential model. So that's our answer, okay? But why are we selecting the exponential model? It's the exponential model because the growth rate is not constant, okay? Because the growth rate of the pattern is not constant, okay? If it is constant, we use the linear. If it's not constant, we're going to use exponential, okay? So that's basically how you construct the explanation to your results. Alright, let's take a look at number 28. It reads, when multiplying polynomials for a math assignment, Pat found the product to be negative 4x plus 8x squared minus 2x to the third plus 5. He then had to state the leading coefficient of this polynomial. Pat wrote down negative 4. Do you agree with Pat's answer? Explain your reasoning. So this is another example where we are required not just to state our answer, but to explain the reasoning behind our answer. Okay, so let's go ahead and rewrite our polynomial. We have negative 4x plus 8x squared minus 2x to the third plus 5. Alright, so what are the terms that we have here? This is the first term. Let's put that in a circle right here. We have the second term. Let's put that in a nice little rectangle. And then we have the third term. Let's put that in a heart. And then we have the fourth term. Let's put that in a parallelogram. Okay, so here we have 4 terms for our polynomial. How do we find out what the leading coefficient is? Let's go over that real quick. So what I would like you to recall is that the leading coefficient is the coefficient, basically the number in front of the variable, is the coefficient of the term with the highest degree. Okay, that's what makes it the leader, because it has the highest degree. So what we're going to do here is write down the degree of each term in our polynomial, and then we'll use that to identify what the leading term is. Alright, so the coefficient of the variable of the leading term is our leading coefficient. For the first term, the degree there is, the degree of the variable is 1, so the degree of this term is 1. Let's change that color to green. So the degree here is 1. The degree of 8x squared, look at the variable degree, 2. The degree here is 3. And then the degree of the constant is 0. Now, which one has the highest degree? It's the heart. Okay? So this one has the highest degree. This is the leading term. Okay? So that automatically helps us to identify what the leading coefficient is. So the term with the highest degree, also known as the leading term, is what? Negative 2x to the third. So what can we conclude? We can automatically conclude that the leading coefficient is the is the constant in front of that variable with the highest degree. The leading coefficient of this polynomial expression is -2. So are we done? The answer is no. Okay, let's go back and make sure we are answering the question. We were asked, do you agree with Pat's answer? Explain your reasoning. Okay, so how do you answer that? You can just say, I do not agree with Pat's answer. Wait, what's wrong with Pat's answer? Pat said that the leading coefficient was -4. Okay? But we got something else. So I do not agree with Pat's answer. We have to explain our reasoning because the leading coefficient um, is -2 and not equal to -4, which is Pat's answer. Okay, so just state that, write that down, and then you should get full credit for this problem. Now let's take a look at question 29. It says, is the sum of 3 root 2 and 4 root 2 rational or irrational? Explain your answer again. Now here we have a chart of the product of products and sums of rational numbers and irrational numbers, the different combinations. If you'd like to gain a copy of this chart and other great formulas for your Algebra 1 Regents exam, just go to mathcodeserve.com under New York Regents, and you will have access to this formula and other great formulas to help you do well on the exam. Okay? Now, the one we're focusing our attention on is rational plus rational. So, I would like you to note the following point. If you add two irrational numbers, I said rational plus rational. I meant to say irrational plus irrational. If you add two irrational numbers, the result is not always irrational. Sometimes it could be irrational, other times it could be rational. Alright, so there's some kind of ambiguity here which kind of complicates the process a little bit. So we actually have to solve the problem in order to know what the correct answer is. Okay, so recall, irrational plus irrational is sometimes irrational, not always. Now, one thing I also like you to remember is an identifying mark of some irrational numbers. Okay, so if you see a number that's reduced, so numbers that's reduced with a radical in its reduced state, that number is not rational, or you can call it irrational. Okay, so numbers with radicals in their reduced state. Now this is key. The state of the number has to be reduced completely. Okay, reduced, or you can call it simplified. Numbers with radicals in their reduced or simplified states are irrational, because there is no way you can express a simplified radical, as a quotient of two integers, which is what rational numbers are. So keep that in mind. Now let's do the problem, since we don't know exactly what it is going to be. So 3 root 2 plus 4 root 2. Now how do you add this? Now let me ask you a question. What if you were asked to add 3x plus 4x? You add just the coefficients, right? So you're going to end up with 7x, because it's as though you have 3 x's and 4 x's, and you're adding them all together, you have 7x. Now if you look at this, imagine as though those radicals are x's. You have 3 radical 2's and 4 radical 2's. How many radical 2's do you have? You simply add 3 and 4. Please, please, please do not add the radicands. Okay? So you have 7 rad 2. Some students might write 7 rad 4 and reduce it to 7 times 2, which is 14, which is incorrect. When you're adding radicals, you just add the number in front of the radical um, symbol. Okay? So that goes our answer. What kind of number is this? Is it rational or irrational? Remember what we talked about earlier? If you have a radical in its simplified state, then that number is irrational. Okay? So let's go back to the question to know how to structure our response. It says, is the sum rational or irrational? Explain your answer. Okay, let's answer it. The sum, you see how I'm starting from what the question asked? The sum is irrational. Why? Because 7 root 2, the answer, cannot be expressed as what? What makes a number rational? It can be written as a quotient of two integers, right? Or ratio of two integers. So 7 root 2 cannot be expressed as the ratio of two integers. It's impossible. Okay? So that's basically what makes it irrational, because it cannot be expressed as a ratio of two integers. So there's the answer and an explanation as to why we arrived at our conclusion. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments, just place it in the comments section below, and we'll be more than glad to respond and support you in getting ready for the exam. Don't forget to subscribe to our channel for the remainder of this review series and other great math tutorials. More clips can be found on mathgotserved.com. Thanks again for watching, and have a wonderful day. Goodbye.